Hi, welcome to Hard-Boiled Synthesis. My name is Marc Lajeunesse, and this course is all about trying to synthesize a research topic using a bunch of tools called systematic reviews and meta-analysis. And these tools form the backbone of a lot of empirically based research where we try to reach a consensus on the outcomes of many studies. My goal for the class is to cut through the theory, go straight to the practical, and actually show you guys all the funny decisions we need to make when we try to complete a research synthesis project. And so this course isn't about learning about, say, publication bias, very important, but not about those types of concepts, but to actually show you guys a worked example of a project. And so let me step back a bit and tell you guys a story, just as a primer for what to expect for the class. So years ago, I completed a project with a bunch of undergraduates in my medical entomology class, where we synthesized, I forget how many studies, not really that many studies, 16, 17 studies that looked at whether or not infected mosquitoes responded differently to repellents. And I loved the project because we were like 30 people, mostly undergrads, working together to collate the studies, code them, and then analyze them. And we managed to publish this study. And what happened when the paper started to come out, I was very excited about it, and I tweeted about the project. But what I did was also kind of like sniffed around Twitter, hoping that other people would tweet about the project. Unfortunately, nobody really did. That's okay. I'm totally fine with that. But here's the thing. Something came up over and over again, which I thought was totally hilarious when I was doing my Twitter searches, right? Because I was searching for like mosquitoes, repellents. These were key words for our project. And this one thing kept coming up over and over again, which was this. Catnip is 10 times more effective than DEET as a repellent to mosquitoes. That's quite the remarkable claim. I mean, 10 times more effective than DEET? If that was true, wouldn't we be covering our bodies with cats right now? Catnip? Wouldn't we be covering our bodies with catnip? I mean, I live in Florida, and we have mosquitoes year-round. If catnip was really that much more amazing than DEET, which is by far the gold standard of repellency, everything would be associated with catnip. You know, you'd go to the store, you'd buy catnip repellents, you'd have catnip growing on your lawn. I mean, so this is kind of an unusual claim. And so this is what the focus of the project is going to be. I'm going to synthesize all the projects that use catnip as a repellent in order to reach the conclusion or to evaluate whether or not it's 10 times more effective than DEET. And the neat part about it is there's an actual magnitude in the prediction that is 10 times more effective than DEET. And so I could actually test that. And how do you test that? Research synthesis, the whole point of the course. And so, yes, I don't know how many lectures this is going to take, but I'm going to go through the entire A through Z of the research synthesis practices, from, say, finding studies, extracting data, analyzing, writing up the manuscript, and submitting for publication. I'm going to do the whole thing for you guys. Again, just so that you guys could see all the silly decisions that are made in order to achieve that final product. And that's really what you don't get with a typical meta-analysis course. Typical meta-analysis course, you go through a lot of concepts. Maybe you read a bunch of published meta-analyses, but you don't really get to see or experience all the funny stuff that's involved in actually generating the final product, the final meta-analysis. And so let's quickly go on Twitter. I'm going to keep a fast pace with this because I don't want to spend all my time on this project. And I think it's, it's a very tractable, just an aside here, I think it's a very tractable project because there can't really be that many studies looking at catnip, right? Okay, so I already did a Twitter search here to show you guys how frequent this proclamation of 10 times more effective than DEET. Okay, a 2010 study, researchers found that catnip was 10 times more effective than DEET. Okay, funny proclamation. There's no study linked with this. There we go. Researchers discovered that volatile oils from catnip 10 times more effective at repelling mosquitoes than DEET. Okay, that's fine. Let's keep going. Now, the dates for these proclamations go way back. I mean, sure, we got stuff from March, right? Did you know catnip is actually 10 times more effective as a mosquito repellent? Actually, did you know? And it goes on and on, We got 2018. Nothing's loading really good right now. There we go. We got mosquito. Researchers discover new pesticide. Okay, we got a weird link here. Catnip 10 times more effective than DEET, but the link is actually about West Nile. Ripley's, believe it or not, tweeting out to the world, catnip is 10 times more effective at repelling mosquitoes than DEET. Ripley's. Let's just quickly scroll down for some more of this stuff. And anyway, you feel free to go do a search by yourself. You'll find that these things go way back. I mean, they go way, way, way back. When Twitter first started, this tweet just kept getting bounced around. 10 times more effective than DEET. Now, clearly there must be like an origin to this really specific claim, like 10 times. And hopefully I'll figure some of that out once we actually get our hands dirty with the research synthesis project. My guess is there's probably is a publication out there that makes that claim. And as I go through all the published studies, we'll find it and we'll be like, aha, this is the one. This is the one where the world has decided that catnip is the best thing. And look at this one right here. Catnip is 10 times more effective at repelling mosquitoes than DEET. DEET is commonly used in insect repellents, but that's a dragonfly. That's not a mosquito. Anyway, that's Twitter for you. Okay, so before starting the project, let me just zoom really quickly into what I mean by research synthesis. It is kind of like a specific tool set. It is not the Wild West in terms of all the things that I'm going to do are have associated best practices. But I'm probably going to deviate from a lot of that stuff, mostly because, I want to get the project done quickly. And so what I'm going to have is a wall of shame, I guess. I don't know what else to call it. Deviations from best practices, where every time I cut a corner or do something that's not really standard protocol, I'm going to put it on the list. And you'll see that and this list is going to get huge. I mean, I'm probably going to deviate from best practices almost every decision I make just to complete the project quickly. And so this is to give you an idea of like, okay, you know what, Mark, you potentially could have messed up at any one of these stages. And I'm going to try to discuss very briefly why the decisions I make deviate from best practices so that you know when it comes for you to actually try to complete one of these projects that you shouldn't quite do what I'm doing, that you should spend more time to think about certain details on and how they could impact your synthesis downstream. Now, synthesis, I've kind of been throwing this word out a lot. What do I mean by research synthesis? I really mean something very specific. And let me jump into PowerPoint here, and this will be the only PowerPoint stuff that I'm going to have for this class. And this is just recycled from my other meta-analysis course. What I mean by research synthesis is basically two branches of two methodologies in which scientists use to combine and compare study outcomes. The one that I am most comfortable and familiar with is meta-analysis. And basically, meta-analysis is like a statistical tool to combine and compare research outcomes. It's heavy on the stats. And if I have time, I will talk about the details of how we statistically analyze the outcomes of stats. These models aren't intuitive per se, but they do have a really firm foundation in how we think studies vary and change and how we could account for that statistically. And so meta-analysis you could split up into two gears in terms of what kind of mechanics are involved in achieving a meta-analysis. Statistically, you want to combine and compare a research outcome. For us, with the catnip studies, I think it's typically going to be a trial where you have a bare arm compared to another trial where you have catnip on the arm and you stick your arms in a cage and the mosquitoes land on the arm. And you count landing times or probing times or feeding times of the mosquitoes as a quantitative measure of how repellent catnip is. Now, the bare arm doesn't necessarily need to be bare arm. That would be a negative control. Because we're interested in like the main claim that catnip is 10 times more effective than DEET, ideally we would want DEET as being the positive control, the baseline for comparison. That way we could actually quantify whether or not catnip is 10 times more effective than DEET. Another key aspect of meta-analysis is like reporting the stats, reporting the aggregated outcomes. And so there's a key part of visualizing and reporting what you find. Now, before you even reach these stages, though, there's a whole other branch of research synthesis called systematic review. And this is a collection of best practices that are associated with creating a repeatable, robust approach to finding studies. And so you begin with clear vision of what you're looking for. So this is called scoping and searching. And then when you find studies, you need to screen them. You need to find the full text so that you could further screen them by actually reading the study. And then you code details about each study and you pull out numerical values important for meta-analysis. And so all these stages here typically fall under a systematic review. And when the systematic review part is done well, the meta-analysis part becomes that much more potent in terms of how well the stats work. And when they work together, oh boy, do we get a wonderful thing. A high quality research synthesis project. Something that could provide information across many, many different studies, perhaps reach a consensus on that information. In our case, reaching a consensus of whether or not catnip is more effective than DEET by, again, synthesizing what's been done already. All right, let me close this. Okay, so let's start. Let's get our hands dirty. I mean, I don't got time to waste. I've already talked for 15 minutes. Let's get going. So the goal now is this phase, which I'm going to call scoping. I really don't know what to expect in terms of finding studies with catnip. I haven't done this before. I have an idea of repellency studies. I've certainly been part of many projects on that, but nothing specific with catnip. And so the scoping phase is for me to understand what I need in order to find all the studies that use catnip as a repellent against mosquitoes. That's my goal. Now, am I going to find all the studies? Probably not. Again, I'm going to cut corners because I need to get this done quick. But I need to find empirical studies, right? Something that does a manipulative experiment. And so for me to at least find a few, I need to get an idea of what to search for. And I imagine catnip is not really the word to try to catch a lot of these studies. You know, scientific literature tend to use more scientific terms, and I'm sure they would probably use a species name of catnip. I'm sure catnip is probably like a collection of species of plants. And so the scoping phase is for me to figure out those details so I can formulate proper keywords to start finding studies. And so right now I'm just going to kind of do a quick Wikipedia search to try to find all the words associated with catnip, so that when I do my search, I could catch those studies that kind of use different words, different ways to describe that one plant. So let me get my paper here. Okay, so let's go on to, Firefox here. I already got some stuff here. All right, I'm just going to do a search for catnip. Wikipedia. Okay, so my goals now, again, is scoping, is I'm trying to find the keywords to try to find all the studies that use catnip as a repellent. And while this loads, I could already tell right now that the species name of catnip is Nepeta cataria. I did not know that. So that will be part of my search terms, is I'll have catnip, the common name, and include the species name, or at least maybe the genus only. So I got catnip. I'm just going to write this down on a piece of paper. Nepeta. I'm only going to use the genus. And then there's also other common names for catnip: catswort, catwort, catmint. Catmint. I kind of like that. So I'm going to write those down also, because they will also become part of my keyword search. Catwort, catmint. Okay, genus Nepeta. I need to know the compound. Now, with a lot of these repellency studies, they're not actually using leaves of catnip. They're using a plant-derived compound, likely an essential oil that was extracted from the plant. Presumably, the catnip has like a secondary compound, a chemical that will be the focus of all these trials, which is presumably the chemical that is the active agent as a repellent against mosquitoes. So I'm just going to quickly zip through here, see if we could find I mean, why wouldn't that be in the Wikipedia page? Is this chemical? There we go. Effects on cats. Catnip contains the feline attractant nipatolactone. Okay, so that's kind of a convenient chemical name. It has the actual genus of the plant in the name. That's nice. Nipatolactone. All right, so that's going to become part of the search, which is the chemical. And let me click on the chemical here, see what it happens. I mean, it's kind of funny, right? This is like a bizarre thing. Catnip may repel mosquitoes, but it may attract cats. It's, you know, this weird, wonderful diversity of outcomes that could come with just this one chemical. Organic compound isolated from catnip, which acts as a cat attractant or mosquito repellent. Whatever our findings will be, we could modify this Wikipedia page with the results. And then I'm not really concerned about what is the actual chemical effect on that. Okay, so I think I got what I needed. I got the common names, a collection of common names. I got the genus of the plant, and I got the chemical associated with it. I think that would encompass the broad diversity of stuff needed to identify many studies. Now, this is where we're going to go to our wall of deviations. My first real mess up. So right now it says synthesis currently perfect, but I'm going to mess all that up because I did, let's be realistic here, I kind of did a quick and dirty job in formulating keywords. And so the scoping phase, you need to spend more time than me than just 10 minutes trying to figure out how to find studies. You need to read a collection of studies to get a good idea of what the words are used, what words, what language, semantic language is associated with your project. And you do not want to just exclude a bunch of potentially relevant studies because you didn't quite use the right terminology to identify which are relevant. So my deviation, my first deviation here will be that in the scoping phase, did not read studies, right? So I don't think I've ever read a repellency study on catnip, right? Typically when you reach this phase, you've read a lot already about the subject and you're ready to kind of tackle it. And you have an idea, a kernel in your head on how to properly approach it. I have no clue. And so this is a first failure on my part in the research synthesis project is I don't know much about the literature. And so here you go. There you go. First failure is I did a really crummy job in scoping, in formulating keywords. Okay, so let's plug in some of these keywords into Web of Science, which is a collection of sources to find bibliographic information. And let's try to find some studies. I mean, I got some keywords. I already kind of did a search for beans here to test whether or not Web of Science was working. Okay, so what I want is catnip, common name, and then I'm going to add a Boolean here of and. So I want to be inclusive of other ways to describe this plant. Catnip, catswort, and catwort, and my favorite, catmint. And now I want to add the genus name to the search term, Nepeta. I'll figure it out. I'll figure out how to pronounce that at some point. And then finally, the chemical name, nepetalone, nepetalactone, sorry, nepetalactone. All right, so here I got the common names, genus, and chemical, the plant-derived compound from a plant. This should be enough to find some studies. And then finally, what am I doing? I'm not doing and. Okay, first mistake. Second mistake already. This is going to go under scoping again. Poor formulation of keywords. Right, okay. I already messed up. I messed up my booleans. And it's like an exclusion term, right? The more ands you add, the smaller the pool of studies you find. What I meant here was or. The more ors you add, the greater the collection of studies balloons. And that's the goal. You should try to be as inclusive as you can from the start. And then once you screen things, once you go through each study, that's when you start dropping things. Goal is to have eyes on the studies, you making the decision on whether or not to include, exclude, not search terms. Don't let the search terms be the exclusion, the phase in which you exclude studies. Eyes better than a database making those decisions for you. Okay, so let's back to our search. Replace all these search terms with or. And then finally, now I want to narrow my search. I don't want all the studies on catnip. I want to narrow my search to studies that use catnip as a repellent. And so this is where I throw in my and. And repellent is a fairly standard word you use to describe this type of experiment. So I'm not too worried that I'm going to exclude or miss out on many studies using variations of the word, but I will add a wild card to the word repel, which will catch most of these variations of like repellent, repellency, repel. I mean, and the wild card is just little asterisks. And that's it. I'm not even going to throw in mosquitoes in there because we may find studies that use a collection of organisms to test repellency effects. And so really all I want is catnips and repel. And then hopefully I'm going to get a ton of things to screen, put my eyes on, and then I will make the decision on whether or not they're relevant, right? So if a study is on cockroaches, I'll know to exclude it. I'll be comfortable with that exclusion because I made the decision. I didn't let Web of Science make the decision for me. So let's do a search for this and see what comes up. Hopefully there's going to be more than like 5 studies. Oh, thank you. Already an issue. Oh, I lost all that stuff. All right, let's try it again. Luckily, all that is... Oh, that's because I got a ton of brackets. And... Yes, missing parentheses. This is the problem with doing... Oh, come on, friends. sign in. Okay, so this is the problem. I'm going to do a copy and paste here of my search terms. I'm actually going to throw that in a Word document because I want to keep track of all these decisions that I make. There we go. These are my search terms. I mean, I might as well just start writing the manuscript right now. Methods. On what day it is? This on December 2nd, 2020. I searched Web of Science with these keywords. There we go. Now, another deviation from best practice. Let's go back to our list. I'm only doing two things. I'm only searching Web of Science, which is a problem. You want to search multiple sources of studies. So I'm only limiting myself to Web of Science, but there are many other repositories of this information you could hit on. Google Scholar is a popular one. I'm not going to do any of that stuff, mostly because I need to move on. I've already talked way too much. And so let me just add this to the wall of shame here. Searching only searched one database. And I'm going to add another one where poorly kept track of database details. Web of Science is a goofy place to find studies, mostly because you don't really quite know what databases they're searching. But there's ways to sniff out what exactly, where all these studies come from. And so what I'm going to do here is, let's save this, head over to the wall of shame, and I think what probably needs to happen is I need to log back into Web of Science. Go back to database. Now, here's the thing, is it's super hard to do a research synthesis project unless you have institutional access to databases and online e-journal access. That is really the super bummer of these types of projects, is if you do not have access to this stuff, either through a university or through a library, you're really limited in what kind of studies you could find. Not all papers are available for the public to read. They're behind paywalls. And let me tell you something, if you're a graduate student or an undergraduate trying to do one of these projects, never pay for a research article. I mean, who's going to pay $100 to read a Nature paper? That seems like the most ridiculous thing ever. There are certainly more nefarious ways to get those papers. Sci-Hub. Yeah. Okay. All right, so let's do back our search. I think I'm logged back in. Let's find out what these keywords have found. Oh yeah, a little bit about the databases. So here I'm searching Web of Science core collection. I'm going to go all databases. And if you ever wonder what all these databases are, you could just, it has to update itself. There we go. We got our searches. You go under more settings, and it's going to search from whatever archives they have from 1864 to 2020. And here is the collection of databases that they searched. I mean, I could copy and paste this and stick it in my Word file so that later when I come back to actually writing the manuscript, I'm going to actually have information on what databases the Web of Science provided. Okay, I need to move on with this. So let's search with these keywords. Let's see what comes up. Oh, please work. Missing parentheses. Oh yeah, okay. I never fixed that weird issue where there was a bunch of existing parentheses. There we go. All right, fingers crossed that there's more than 2 studies. 244. I mean, you could refine your search, right? I did a huge search including patents. Maybe the patent literature is important for repellency experiments, but my experience and my gut feeling is they tend to not provide actual experimental results within a patent. They just say, hey, here's a chemical concoction that we derived. It has these properties. They don't actually report that this is, 2.5 times more effective than DEET. But I'm going to search these and include these in my search. Maybe there is a patent out there that actually reports a numerical outcome useful for synthesis. But anyway, I got 244 with just the funny search terms that I pulled together quickly. And let's quickly zip through some of these. And I can tell you right now, some of the top hits are just like totally nonsense. I mean, Drosophila, repellency of Drosophila, evaluation of lotions of botanical-based repellents. Okay, so this study probably includes a catnip. Not an ideal study because the catnip is probably tested with a collection of compounds. This is not unusual for repellency experiments. But here, okay, so repellency of catnip oils on bed bugs. Not relevant. And so, okay, there's stuff out there. Okay, so the final step, I'm going to quickly get this done, is just to download these. You go to export to file format. Web of Science is bizarre. It only allows you to download 500 things at a time. I mean, what can you do about that stuff? And I want abstracts, so I'm going to include all that stuff. And I'm not going to use the tab delimited UTF-8. UTF-8, you're going to get, I think, I always get these backwards. You're going to get a whole bunch of weird characters. And you'll find that because I'm going to use R a lot for the screening and analysis part, weird characters just don't work well. R doesn't digest weird characters very well. And so we want to avoid using non-Roman characters, I don't know what you call these things. But anyway, you don't want a bunch of goofy symbols messing up your references. And so I'm just going to use tab delimited for Windows. I think that's not that might be a lesser format, which is just ASCII code. And R loves ASCII, does not love other things. And so we're going to export that. Basically, it's going to collate these 244. That's fairly straightforward. Sending it to file. And it needs to think about that. I mean, I guess I could open it in Notepad. You're not going to be able to see this. Okay, so there you go. I saved it. I'm going to end today's lecture with that. Maybe provide let me just quickly summarize what I did today, what the point of the course is. My goal is to synthesize studies that use catnip as a repellent to mosquitoes. I want to test this claim that's floating out there where catnip is 10 times more effective than DEET. To me, this is a bizarre claim. I feel like there's some sampling error where a study just did not have adequate sampling and achieved this result. I'll talk a bit about that in the following lectures. And so I did already 2 phases in the systematic review synthesis part, where I scoped the literature. Not quite, right? I could just kind of pull this out fairly quickly. I pulled together a bunch of keywords. I'm interested in finding catnip studies. And then I searched Web of Science to try to find those studies. I broke a lot of rules already, right? I spent little time formulating my keywords, and I only searched one database. So what you need to put in your back pocket is, if you're going to start thinking about a research synthesis project, read the literature beforehand. I'm sure right now there's probably a published review of catnip as a chemical, as a repellency, as an attractant, which would have been incredibly useful for me to formulate really precise keywords to identify studies. Didn't do that. 2, I'm probably not going to find the entire domain of knowledge associated with catnips as a repellent, because I've limited myself to a single database, Web of Science. You're probably going to want to hit on multiple databases to actually get a better collection of studies to synthesize. Other databases include, open access dissertations, Google Scholar, although Google Scholar really is like a funny black box. It's not really like a database search. Google tries to answer questions. That's what its goal is. And when you do a search on Google Scholar, it's trying to provide an answer for what you're looking for. It's not giving you a straight up conventional database output of all the things associated with that search criteria. It's trying to provide an answer to your query, which means that it's going to provide a ton of stuff that's not relevant, but a ton of stuff that might be what it thinks is what you're looking for. Web of Science doesn't quite do that. It's actually searching the abstracts and the titles, and then it has its own formulated keywords that it searches. So basically, it's like, okay, I have 1 million studies. Here are all the studies with catnip. Google Scholar, on the other hand, probably has like 10 million studies or more. And it says, oh, you're looking for catnip. Here's what I think you'd be interested in, which is kind of a very different approach to finding studies. Now, the neat part about Google Scholar is it actually searches the full text of studies. And so you might catch a few odd eggs that do report what you're looking for, but is not reported in the abstract or title of the study. There are limitations, there are advantages. The compromise is just to hit many different places to try to find your studies. Now, of course, you need to keep track of all those searches that you make in order to make it repeatable for other scientists to evaluate what you've done. Repeatability is crucial because again, you could deviate from best practices at any point in a research synthesis project, and that might impact downstream what you have in order to reach a consensus on multiple study outcomes. If you do deviate, that's fine, as long as you're open to describing in detail what you've done, right? Make things as transparent as possible. Okay, so next lecture, we are going to do the super dull part, which is screen all of these things I downloaded from Web of Science, include, exclude studies. Again, I'm just going to quickly eyeball these things for studies that basically test on mosquitoes. And then we will begin to try to retrieve those studies, actually get the full text so that we can start pulling out numerical values for meta-analysis. Anyway, I've talked for too long. Take it easy.